Hello, hello, everyone. Welcome, welcome. People still joining. Good morning, good afternoon, good evening if you decided to stay up late and join us. I'm just going to give everyone 1 or 2 more minutes here to filter in, but I'll quickly introduce our workshop here today. So yeah, we're trying something new out in actually this program. This is the first time we've done a workshop like this, so hopefully it goes well. But we're very lucky to be joined in the program and in this workshop by the Stability team. I think you're here, so I don't need to introduce what Stability and all the awesome stuff that they're doing. We're gonna have 2 workshops today. I think in terms of just how it'll work, at least this is the plan, is that we'll go through the workshop, and if you have questions as the workshop is going on, just put them in the chat. And then, if we want to answer them as we're going, we'll do that. Otherwise, probably save time at the end of each workshop to kind of specifically go through the questions. Yeah, if you have any other questions about how it'll work, just feel free to drop it in the chat now. Otherwise, yeah, I think I'm gonna kick it over to Dakota for our first workshop here.
Great, thank you so much. Hello, my name is Dakota Mahan. I'm a research scientist at Stability, and I have a presentation to start with, and then we'll go with a quick demo, and do some question and answers after that. Today I want to talk to you guys about LLMs for code and beyond. Beyond is definitely huge, but here's a brief look at our beautiful faces over at Stability's language and code AI teams. You can see all of our beautiful faces, and my picture is actually my profile picture. Since you're already seeing me over here, it sounded more convenient to give you my profile picture if you ever decide to look me up on Discord or Twitter. I just wanted to give you guys a quick introduction to large language models. So just some background on, how this all started. So way back when, we used things like n-gram language models or hidden Markov models to do NLP. And these did work as a language model. They could predict the next token, and they were, the basis of understanding and generating human language way back when, 10 years ago. But
Dakota,
now,
sorry, do you have slides that you were presenting?
yes, does it not show?
It's not showing.
Oh, goodness.
No, all good. Thank you for the heads up, yeah, they're okay. Now we're in.
Got it. All right. Let me oh, get back into it. You did not see our team's beautiful faces. So I'll bring that back up. Sorry about that. Um, Here's our team at Language and Code AI teams at Stability. Everyone there. And then I'm in the bottom right corner with the Raven image. That's my profile picture. So if you ever see me on Discord or Twitter, that's who you're talking to. Back to that slide thought I was showing you guys. This is about traditional foundations in NLP and how it evolved to language models. Talked about the n-gram and the hidden Markov models, and so we've gone way past that. Now we're into large language models. We have billions of parameters, trillion terabytes of data going into these models, and we're just now starting to look into like how these things work precisely, right? There's a lot of interpretability research that are going into this. Give you a brief look at how the n-gram models worked. So there's a database of every single part of text here. So, like if you have a 5-gram language model, you'd have 5 tokens. And so, here you can see like, hi, my name is, and what's the next gram for this 5-gram language model. So on the right, we have John being 300, Jane being 224. The way n-grams work would be to calculate like each count that these, tokens appeared in the database. So, John here we have for 300, Jane for 224. And so, someone drawing on my screen, or is that just me? sorry. But yeah, basically we turn these counts into a probability. We count how many are in total in these database. So like, let's say the answer is 500. So we'd have like a 30% for John, and then like a, um, 44% for Jane. Um, so yeah, and then now we're in the deep learning phase. So we throw it into a giant language model. Maybe we have a vector database for retrieval augmented generation. But it all gets thrown into this language model, and we get probabilities directly out of it. So 30% for John, 28% for Jane. And we use large language models daily nowadays. There's personal assistants, Siri, Alexa, ChatGPT, all those. People talk to them, they have them do things for you. Customer service, talk to, you know, whoever, your electricity company. You talk to them, they probably have a chatbot hanging out, answering common questions, dedicated translations. So, obviously, I think many people here have used Google Translate, among others. Put your, English in and get out, Spanish, German, what have you. And then style transfer agents. So, summarizing text, changing tone of text, rewriting text, all those things are being used by large language models nowadays. Excuse me. And then, yeah, large language models and coding. So there's a lot of stuff going on nowadays, automated code generation, code optimization and refactoring, and automated documentation. I think most people here have used GitHub Copilot, or at least heard of it, and I've seen it, generate entire, functions from scratch. I think some people here are probably seeing, agents being used to generate pull requests, among other things. So it is definitely an exciting time here for code language models. And then, stable code is one of our stability language models. It's publicly available. It's a foundational language model. It's trained on 560 billion tokens of code. It's multilingual, so it supports, Python, C, and quite a few other languages. So when you're, typing away, it'll support a lot of different languages for you. It's one of the first models actually that supported up to 16K context, which is about 5 Python files. I know a lot of you have seen, stuff like Yarn where it's 128K nowadays. But when this was first published, that was not really in the realm of possibility for such a language model. So now, we're able to generate entire functions or single multi-line completions like GitHub Copilot with this model. It's small, but it's very well trained, and it's 300 billion parameter. Sorry, 3 billion parameters. So anyone's modern laptop should be able to run this very easily. Yeah, I wanted to get a quick demo here about running code completions locally. And so here's some stuff you can do. Go to this GitHub page, clone it, install the requirements, and then run the function here to start it up. And there's a VS Code thing here, LLM VS Code. Have to install that, and then change the model ID to the endpoints here. So I'm going to go ahead and switch over to VS Code here for this. So yeah, just have this quick page here set up. And so I'm running it already. If I can get the command prompt here, so you can see it kind of running here in the background. So if I, do something different here, define hello world, and then let's see what happens. Okay, it should be sending over to the thing. Yep, here we go. So here you see it's trying to generate a model and tokenizer with BART. It's doing it again. So yeah, let's go ahead and try to get it to use this model. So let's try to get it to create some tokens for this. Okay. maybe if we just start with tokens equal, it'll come up with some completions here. So yeah, it'll just keep going here and do all kinds of interesting things. It sometimes gets stuck in loops and try to, do some the same thing over and over again. So let's try to get it to see what it can do with if we just give it some function name here, for example, for a web page, see what it comes up with. Okay, so it's trying to open a web page with a file and then tries to tokenize it and print it out. So yeah, that's just a brief overview of how you can use code models in everyday context. I'm sure a lot of you have already tried GitHub Copilot and everything, but you can also do that with local models like stable code. So and there's so much more stuff you can do with code models. So but I think that covers the scripted portion of this session. So if you wanted to go into some question and answers, that would be perfect.
Very nice. There's a few questions in the chat here already, which is about can it explain code? How does it work for different languages? If everyone has any other questions also, yeah, please throw them in there.
Yeah, so I guess I'll get started with how does it work with other languages? So there's nothing really special about the model and how it's talks to different languages. It's all the same tokenizer, same model. So you just send in the raw code, whether that's a bash script, a C file, a Python file. They'll take it in the same way and output it in the same way. It just takes in that context of the language that you're using. So you're going to, I assume, start with something that's not just a blank page, right? Usually there's some defined main if you're in Python, or if you're in say C, there's void main. But it should be able to pick up that context and then say, oh, I'm doing this, and then the output will be in the same kind of style. So hopefully that answers that question.
Yeah, I can actually try to bring people up on stage here to ask their question. Maybe let's see, Chris, where are you, Chris? If you want to come up and just ask your question live. Oh.
Yeah. Yeah, I was just wondering about with websites and being able to code for them. I wanted to kind of include generative tools into the product I'm building. I just didn't know how this would do with trying to do that because I'm a little rusty on my HTML and JS code and shit.
Sure, sure. So yeah, definitely. JavaScript and HTML should definitely be covered in this model. I can't, speak to how crazy you can do things. If you're using some very bleeding edge HTML and JavaScript, obviously this was trained a little bit ago, so it may not be able to do something at the bleeding edge. But definitely, for a lot of the grunt work, it should be able to, get in there and do it for you. So here, I think I'm still sharing my screen. So if we do, um, in here, we do something like, oh, say, add a div to the center of the web page. Hopefully this gives us something similar to how a div would look like in HTML here. And so let's see here. You know, Okay, it should be thinking here. So let's see here. Let's try to prompt it. Start with, that. Yeah, you can see it's starting to do it once it starts getting some, format text in there of being a HTML document. So yeah, definitely can do stuff like that.
Do you have any notebooks available that we can use to fine-tune this model?
We do not have anything specific on this model itself, but anything that's like Hugging Face should be transferable over to this model as well. So if accelerates or anything like that, any training scripts using that, you should be able to just transfer it over to this model.
Other questions for Dakota? I think John had a question about which library you use for inference.
Sure. So I guess this one specifically here is running with Hugging Face VS Code endpoint server. And so that was part of the presentation I shared here. I think people are going to be getting this afterwards as well.
Yeah.
So yeah, it's definitely it's in here. You can get clone the repo and everything. But from like a what other things you can do? Obviously there's the Hugging Face text generation inference server. That's always a good one to recommend. And there's all kinds of other ones. Let's see. I don't know if any of the quantization libraries are able to run this one off the top of my head. Sorry about that. But definitely, text generation inference server can run it, and that should give you some good throughput in your numbers.
David, did we unmute here?
Yeah. Should I ask now or?
Yeah, bring it on.
Yeah. Sweet demo, by the way. It was really cool. I was wondering about, I'm using an editor now, and I may have missed this in your presentation, but I thought it was you're using code generation in your coding process, like when you're coding. I'm using this tool now, Cursor. I don't know if you've heard of it, but it's basically like autocomplete on steroids, and then you can highlight text and it'll explain the code. I'm wondering, like, are you doing something similar here, and could you compare it if so?
I think Cursor's probably doing something different.
Okay.
Yeah, we definitely don't have the ability to like highlight code and have it go into like an explanation on it from here. But for as far as like autocomplete is concerned, I think it's probably similar in how we're doing it here. So, we
Amazing.
have some of the stuff there, yeah.
And then how much of your code do you think you're using that you're saying you're completing with it? It probably depends on what you're working on, but
Of course, yeah. When we're doing a lot of like crazy, large training run code, sometimes, it's not necessarily the best to rely on the auto generation process to help with that.
yeah.
But for a lot of things, like a lot of the synthetic data generation we've been doing, it's able to, just do a lot of the, I guess, grunt work and say formatting text to send it to a language model, and then taking that, formatted text back and extracting it into something that we can then send over to, a JSON or what have you. So yeah, definitely it's doing a lot of legwork when we're exploring, synthetic data generation and stuff like that.
That's amazing. Very cool. Thanks.
Thank you.
Hey, thanks for the opportunity, Joseph. Just wanted to understand a bit more. what sort of languages, which all languages are you supporting? Primarily, I'm concerned about object-oriented languages like Java, C++, or something like that. What's the accuracy level in that case? And how well does the product align with RAG models? We are building our own RAG AI-based product, so we just are concerned about the accuracy and efficiency of whatever the output is being generated. Thank you.
Of course, yeah. So let me bring up the numbers here. Because I think we had those on one of the evaluations we ran. But I don't have them in front of me right now. But I do know that we definitely do most of the object-oriented, sorry, not most of them, the popular object-oriented languages like Java, C++, C, and Python. So those are all inside of it. So I know those are in there, as well as HTML and JavaScript. As far as the other ones are concerned, I want to say off the top of my head, Go is in there and Bash script, but I'm pretty sure it's in our Hugging Face page. We have the languages that are supported, as well as any benchmarks that we have available on there. But for your second question about how well it can do with like retrieval augmented generation, this is a base model. So what we mean by base is that it's not trained to follow instructions very well. So it should, in theory, like if your retrieval augmented generation is more or less putting a bunch of Python code files together, I think that is definitely in its possibility of working with that, using that as like the background for the current page you're in. But if you're trying to do things like take instructions, for example, from a documentation page, that'll be something it'll struggle with.
I'll keep the questions rolling, but Scott, also let me know when we should switch over and do the second workshop here.
Yeah, I'm ready whenever you are. So if you notice a lull in the questions, we can switch. Otherwise, keep them coming.
I think we made it through most of the questions here, so maybe this is a good time to transition.
Sounds good. I'll still be on the call, so if anyone has any other questions, I can monitor the chat and we can do some asynchronous question answering. So thank you so much for your time, everyone, and I'll leave it up to Scott.
Yeah, thanks, Dakota. And yeah, by the way, we have this recorded if you want to check it out again, and we're obviously connected to the team at Stability. If you have questions as you go, if you explore stable code and have some question, we'll make sure to get it passed along.
All right, I'll do my song and dance now. Hi, I'm Scott Detweiler. I'm the head of quality assurance here at Stability. So I break things professionally. So I'm going to do today is I'm going to show you ComfyUI. So if you're not familiar with Comfy, you will be by the end of that call here. So I'm going to start out. I'm just going to share my screen here. I don't have much of a presentation per se, more of just kind of some fun stuff here. Where is, okay, my screen. Let's do this one. Right. And let me know if you're having difficulty seeing that or not.
Nope, we can see it. Looks great.
Okay, good. I cannot see anything. So, all right. Well, there's the chat. All right. Okay, so this is Automatic 1111 for all of you who are not familiar with that. This is pretty much probably the most popular graphical user interface for our for using our models. And everybody's kind of taking it home and running on their own machine. And I use it. I have used it for a long time, and I know it pretty well. Now, this is an older version of it. If you notice, I haven't updated it in a while. If you're used to looking at it, it's because I don't use it anymore. And why? Why did I get away from using it versus the other things that are out there? So let's just talk about this first. We'll look at this briefly, but that's a very simple user interface, and we're focused mostly on the prompting, right? So the whole idea behind this engine is really focus on prompt engineering and develop a skill set there to talk to these models and get the most you can out of them. But if you want to do something where, say, you want to implement some LoRa's or something, you go down, you find your LoRa's, you pick the ones you want there, you pick different checkpoints, you do different textual inversion things, whatever, but you're basically going through the user interface and finding the button or switch you need to flip and then making it happen. But what if you want to run multiple LoRa's back to back? What if you want one LoRa to be from the first, say, 20 steps and then use a different LoRa for the remaining 30 steps? What if you want to use certain parts of the weight blocking for a specific LoRa during a certain time step? I mean, it gets very complicated when you know what you want to do. And the idea behind this is not so much to focus on the prompt engineering part, but to focus on the workflow that drives the prompt. And that's where Comfy comes into play. So Comfy, here, this is a typical Comfy graph. You can see me doing serious business here, where I'm taking pictures that I've generated of Victoria and Lemon here, and then replacing them with Mr. Bean's face, because I can, basically. And the workflow is not that complicated. But what's nice about this is that once it is done, now I can fall back into that kind of mentality of the automatic 1111 universe and focus on specifically the prompt engineering behind this, knowing that the rest of the workflow will continue to work as it should, meaning it's going to replace everybody with Mr. Bean's face, which is the goal here. But a lot of people look at this and like, wow, that is really kind of a complicated spaghetti together of things, where in my mind, this kind of opens you to doing really whatever you want to do in whatever order you want to do it. And that's the reason why at Stability, this is what we use to do a lot of our heavy lifting internally. So if we're working with a new model and we want to do some sort of workflow with it, we use this product, because Automatic 1111, although it's a fantastic tool, it really does not have any sort of a, you want to call it freedom to it, because we're reliant on, first of all, the developer who doesn't work for Stability. Now, the guy who writes Comfy does work at Stability. So when we need something done, he simply adds it to the product. But the other benefit of this product is that a lot of people contribute nodes or extensions to it. Now, Automatic 1111 has a very similar thing, but in Comfy, it's a lot more pervasive. Comfy itself has a very few internal functions. In fact, math is not even in the product. I mean, it doesn't do a lot of things. So when we right-click to add a node, for example, and you see add node, you click on it, I have all these external libraries that are added, and all of the people that write all these different things all maintain it themselves. So whenever there's a new node that comes out by somebody, I can feel free to go ahead and use a git pull on that, and it will update it, and I'm ready to go. So it's updated constantly. And because we can chain together all of our different nodes, we can kind of interspace them and do whatever we want to do. So if I want a LoRa for a certain time step, and then I want to switch to a completely different checkpoint for a different time step, I can do that. So I thought I'd do is I would kind of walk through a little bit of that there. So reading some of the questions here. Your chaining prompts here. Actually, what I'm doing, I wasn't going to walk through this workflow, but I can walk through it briefly, well, maybe I'll do that in a second. Let me start with a more basic workflow. We'll go from there. So Comfy basically starts out with, you're going to start out with loading a checkpoint, just like you would in Automatic 1111 or something else. And then from here, we basically take these nodes, and they're color-coded to help you kind of keep track of what's going on. But if we pull this out, it'll guess at what we're trying to do next. So we could just clip text and code. This is your prompt. This is one of your prompts, and then there's a positive or a negative. So we probably duplicate this, which is very easy to do by holding on Alt key. So now we have a positive prompt and a negative prompt, and I can go ahead and I can color code these. So if I want to make one green and one red, for example, then I can kind of keep track of what I'm doing so I don't get lost. And then what I want to do with these is I want to sample them. So if I pull this out, you can see it's guessing that, now there's, again, a lot of things that are added to the product here. I have a lot of nodes that are added after the fact, because again, the base product doesn't have a lot to offer. Comfy designed this product to be a backend first and a user interface second. That's why it feels a little kludgy from time to time. It's using an 8-year-old node system called LightGraph, which has been on GitHub forever, and it's just implementing that. Now, there are other user interfaces that are coming out that are using the Comfy backend, and there are several of them, but just note that it's not really meant to be a front end, wow, fantastic feeling, good to use, fun to use product. There are a little bit of things you have to get used to it from a user interface standpoint, but it's focused on workflow, not focus on the user interface so much. So in this case, we'll use a K sampler, which stands for, this is Catherine's sampler, so she works at Stability as well. And we're going to pull this. So this is a negative here. We're just going to plug that in. And then we have the model, which is still over here from when we loaded our checkpoint. We can just hook that up. Now, obviously, you get a little spaghettification going on here, and I can drive the OCD into overdrive, but you just kind of got to look past it. You can also change different aspects of the way the graph is rendered as well. But again, it's very rudimentary in the way that it works. And then a latent here, we pull this down and we can say, oh, I'm just looking for an empty latent. So your empty latent is obviously your noise, your initial noise. And here's where you set your resolution for your image. So if you want a 1024, because it is an SDXL model, for example, then how many images I'd like to create with each batch, I can do that. And so the other benefit of doing this, by the way, is we are learning how this actually functions. It isn't a matter of just typing in some sort of prompt and getting sort of waifu out of the end of it. You're actually learning about where the prompt conditioning goes and how it's handled in the sampler. You see the actual, I mean, obviously from a rudimentary standpoint, you see how this is functioning. It isn't magic, which is the reason that I really like this product. From here, we then need to use a VAE to decode it. And where's our VAE? Well, most of the time it loads in with the model, but we can also use a different VAE. We can mix and match them at any time. In fact, if we wanted to, we could use this sampler for, say, the first 4 steps, and then use another sampler and continue to kind of chop the time steps up and use different checkpoints if we wanted to. It's very interesting how you can link them together. So from here, I'll just put this VAE over here so we can get to it. And then over here, we can just pull this out and we can save our result. This is more or less exactly what Automatic 1111 and Comfy do as a base graph. It's very rudimentary, but we can add things like LoRa's in here. So we can use add node. There's loaders for all kinds of things, different control nets. Basically anything Automatic 1111 can do, this can do as well, but there's a lot more memory efficient because we're not loading in that giant model and all the other giant product and all the other things that come along with it. It's only loading in exactly what it is that's in the graph and nothing else. So it runs on more of a potato computer than Automatic 1111 will, and it runs faster on the same hardware. So in this case, let's just load in LoRa, for example, and I have a Caravaggio loader here, or a Caravaggio LoRa, and you can see again where it fits. Like when I first looked at LoRa's without understanding how it actually ran, I would assume that a LoRa would fit in somewhere over here. It's kind of a part of the pixel manipulation. It's just my Photoshop in me. But I've since learned, just because obviously this product, that it actually fits in way back over here. It fits in between the model. So it's bolting on information to the model. So the model is not modified. If you have models that are trained, say we go and we fine tune a model or we create a new checkpoint, you can have just tremendous unforgetting, basically, tremendous forgetting, I should say, where you'll lose a lot of the base model's information because you're overwriting it more or less by trying to fine tune aggressively against it. So by using a LoRa, you have a much smaller kind of bolt on to the original model. So the original model is frozen, and the LoRa lets us add new terminology or augment existing terminology, which is pretty refreshing. So from here, we've just stuck the LoRa in the middle. We put our clip. The clip is your language model, your contrastive language image preprocessor. That's the thing that kind of, it's the graph of terms versus the graph of the imagery. And from here, this is what will feed this into our conditioning. And if you want to do something like in Automatic 1111, you see things where it says the prompt is more important, or the LoRa is more important, or control net's more important, is actually, you can do that in here as well by just simply ignoring, let's say, for example, we don't even put the negative through the LoRa. We only put the positive through the LoRa. So we can do different little things like this and nuance how the whole thing connects together, which is pretty interesting to me. And that's basically how this works. And if we want to do image to image type of work, for example, a lot of people do that. That's basically our latent down here is an empty latent. But if we wanted to take an image that already existed, we'll say we image and we load an image here. I just have a wave. Basically, what we're going to do is we're going to take this and recode it back into a latent. So we can take this and we can take a mask if we wanted to. So again, I can mask off pieces of the imagery I'm loading in. Again, we need our VAE. And instead of this latent, we can use this latent. And now we have, instead of an empty latent, we have this. And now you're basically viewing an image to image. So we can do that later down the line too. So if we started with the empty latent here, for example, and then later on we say, well, I really want to take, and now I want to take whatever this image was here that we produced, and now I want to use this and go through another K sampler. And we can actually do this a little more efficiently too. When we copy and paste the nodes, if you hold down your shift key, it keeps all the connections together. So now I can take this latent and continue onward, just reinventing things constantly. So the ability for us to do really anything that we want to do in any order we want to do it becomes a reality, which I love. You can really play with coming up with your own creative workflows. So here's, again, taking a base prompt with a LoRa and a negative prompt, producing an image, and taking that image, re-encoding it, and putting it through another K sampler. And we can do this at a lower denoise here. Say we're going to keep only 45% or 50% of it, and then bring it out and save that image. A negative LoRa, you can just make a LoRa and attach it through the negative side. Again, a lot of this stuff is just kind of like, oh, well, that makes perfect sense, right? But a lot of this, the graph is basically experimentation. It's taking an idea or a concept and then working with it to see what you can get in the graph. So if we go back and we look at this one again, you can see, now I'm using a couple of, again, really kind of interesting nodes here. One's called a 2-pipe node. This is from an Impact Packs. Again, another person who writes a lot of nodes for this product, just an independent developer named Lieutenant Dr. Data, I think is his name. He's the one who wrote this manager too, which is this thing for managing all the different nodes or different custom nodes that we have in here, because we have a lot of custom nodes. There are hundreds of custom nodes now, and all of them do different things, from half toning to video to whatever. And you just load them in. Now, each one has its own possible train wreck of errors as well, because again, there's no quality control for that. That's not our job. Our job is to create a product that's a base solid product, give you a fantastic model for you to use it, and then for you to kind of figure out what you want to do with it. And everybody has all kinds of great ideas. Like this 2-pipe is probably implemented in 4 different libraries in 4 different ways. So everybody says, oh, I really don't like all these noodles running around. I want to combine them into one pipe. Great idea. Well, 4 other people thought it was a great idea too. So we do have some considerations in the future as this product grows. How do you control random stuff that people are adding to the product? If everybody's adding their own, say, integer to text converting node, of which there's probably 8 nodes in here. How do we decide which one is the best one or the one we keep? We just kind of stopped deciding that, or never really kind of took the onus of deciding it. We're kind of letting the community determine how that's going to work. And so far, this worked out great. But some libraries are more popular than others, and some have been abandoned that are fantastic libraries. But other developers pick them up, and then we'll fork those and continue to move forward. It's all part of Git, so you can go up to Git, fork your own, and do whatever you want to do there. So if we go back to this one, just look at my example here, and then I'm just again putting it through a K sampler, and then I'm taking whatever that image is here, and you can see a branch, and it goes down here. Now down here, I'm doing something else. I'm actually intercepting that and adding another prompt. So I'm injecting another prompt into this. I'm basically replacing the existing prompt. I'm automatically building a mask for the face here. So I'm using this Ultralytics provider to find the face. And then I'm creating a bit of a dilation around it, so the mask is a little bit bigger than the face itself, and a threshold for detection. And then I'm going through, and this is the mask for the face that it created. And I'm going down here and I'm basically saying, I want to take this and I want to prompt only in this region the following Mr. Bean face using this mask. And so here's my sampler for that versus here's the regular sampler for everything else. And then you see what it did. Now, what's interesting about this technique, this is this regional sampler is somewhat interesting, is that it does not just restrict itself to only the mask area. The mask area receives the majority of the work. But you'll notice that slight things like the bracelet, for example, is nowhere near the face, but the bracelet is missing, or the fingers might be slightly different. So it's taking into context those changes in the face and trying to follow through with the rest of the image. This is a really interesting, again, custom node that somebody made. He also has the same one where you can inject a seed change into a specific part of the image now. And that's brand new. I think that came out yesterday. So the ability to take a mask and say, in this area, focused around this point in the mask, I want you to change the seed to a specific seed, and maybe only 50% weight, or maybe 30% weight, or actually 2 or 3 seeds blended at different weights, so that you can kind of take your bits and favorites and change it out. Now, that's not as predictable as this is to me. So this is one of those things that I kind of really like. But yeah, so that's how we change people into Mr. Bean there. So I'm going to look at your questions here. Let me scroll up a bit here. I see you guys were chatting while I was working. Do I need an AI assistant to build these workflows? The funny thing is that there's not a whole lot of workflows that really need to be made. I use this workflow all the time, and it's generic enough. Again, it finds the face automatically. I don't have to go in and use a masking tool to paint it in, because let's face it, those tools kind of suck. This does it automatically, and I can use any sort of clip segregation. So if I'm using any sort of segmentation, so I can go ahead and say, I want a car to be highlighted. It'll find the cars and create a mask for the cars. So you can use it by name as well, because you have clip involved. So again, we have language we can use. So I don't think that I probably have maybe 7 or 8 workflows that I depend on a daily basis. And outside of that, it's more of experimentation. So it isn't like every time I go to create some sort of a picture and say, hey, today I want to create these pictures of this exact idea. I don't start with a new workflow every time. I start with an existing workflow and then focus on prompt engineering, because the workflow is what I want it to be. Well, I mean, keep going here. Going to mention the company was on my 3070 because you could not get SDXL to work on Mac 1111. Yeah, it'll run on a lot more hardware, and it runs a lot faster. In fact, we just added the latent models just got added to this a couple days ago, and I can get an inference in around a second now. So I can create if I had a 4090, I hear that that's as good as 0.0 or 0.7 of a second. So very, very fast. Let me look through here. Is there a negative LoRa? There are, you can use, again, anything, the positive or negative. It's simply a bolt on to the clip model, so it's injecting in there. So yes, there are negative LoRas. In fact, there's some that a lot of people are depending on for like bad hands and things like that, because let's face it, the models don't understand anatomy very well. So you get like 5-legged horses too. It's just a matter of things. I think that in a couple of years we'll look back and go, I remember the days when I couldn't get 5 fingers on a hand. Do you remember that? I miss those days. It'll happen. We'll get to that point. How do you train high quality or high resolution LoRa over 4K? I don't do a lot of training, to tell you the truth. I say that is in the research side of our business, and I work with those people, but what they're doing is what they do, right? So I'm more on the quality assurance side. So whatever they make, I try and wreck it. That's my job. 4K ultra sharp got very poor quality. There's a lot of different upscaling models too in here. I didn't show upscaling as part of this, but you can really use any upscaling model. I mean, they're all out there. Yeah, there's a lot of different ones up here. Love the way the engineering was allowed for so many functionalities. Yeah, it's if you used Substance Designer, you've used Blender's nodes, you've used Houdini, or you've used blueprints inside of Unreal Engine, all of them use this same node configuration, because it really does not limit you in the way that you want to work it. So if you come up with some sort of crazy idea, you can just do it. The only thing that's going to happen is you might spit up blood if you're mixing models. Let's say the shapes are inconsistent, or you have the tensors wrong. Those are not really things that you can control. I think the thing we have to keep in mind is that we are on the bleeding edge of this, right? So this isn't a product that you just go to Best Buy and you pick off the shelf and you take the CD home, if we have CDs in our computers anymore, and you load it in there, and now, hey, look, I can use this program. I bought it off of Steam. It works, and I'm going to complain to the developer. There's a couple bugs. This is not the universe that we all live in right now. We are bleeding edge people. So every day, like, I did not use a new version of Automatic 1111 because I don't know how stable it is. And in truth, I didn't want to test that ground before doing a demo for you. I wanted to have that page come up, and I wanted to have it work. So I just used an old one, because let's face it, we've all pulled from the Git and then run it, and then it breaks and you have to go back and revert. And that's just part of the world we live in right now, right? It's just all bleeding edge. And unfortunately, or fortunately, that's what's going to happen. And I love the fact that, you got to appreciate the fact you guys are really on the bleeding edge of kind of this whole thing. Imagine when the internet first came out. I remember having to actually address emails by each no-hop they went through of each mail server that was running. And I mean, that was a long time ago. And little did we know that was what the internet would turn into at some point. We are at the base of this whole tree here too. This is, like I say, it's akin to steam power. Look where steam is going to take us. Soon we're going to have cars, then we're going to have rockets. But it won't take us a couple hundred years, right? We should be able to do a lot faster than that. So do you have any other questions? Feel free to chime in here.
Yeah, just raise your hand if you want to just come up on stage and ask them as well. We'll put them in the chat.
Thanks, Scott. I asked in the chat, but I didn't know if you got to it. I always heard that the color coding was not universal, that don't follow it, just try and bash it till it works type of thing. Did that change at any point, or is that like always been that way?
I think it's always been this way. I mean, that I remember, images have always been blue, the models have always been pink. Clip has always been yellow, and conditioning's always been orange. But I don't really kind of depend on that. I kind of know where they're supposed to go now. I think when I was first learning this, that maybe I got used to looking at those colors. It's helpful, I think, initially, but after a while, you kind of get used to where they go. And there's all kinds of little things in here people don't know about too. Like, for example, if you don't like this basic pipe, you can actually rename this slot to something else. So that you can kind of keep track of them. A lot of people don't know there's little tricks like that in here, just to kind of help you organize. There's also subgraphs, which are coming, but that is so experimental right now that anything you do with subgraphs could break when they release a new one up tomorrow. So I haven't really kind of pushed a lot of those things. In fact, a lot of the things I see that come out, I don't talk about, like on my YouTube channel, I kind of skip it because I need it to age a little bit so that we understand, first of all, that it's not going to instantly break everything I've been making. And again, my 14 or so workflows that I depend on, I really have to make sure those work in order to do what I'm doing. And if someone releases a new tool or a new node with now a new variable on it, suddenly all my workflows break. So I have to be careful there. And we all have to be careful. And especially as this gains more momentum commercially, then the people who are making these nodes are going to start to be dependent upon for what they're doing. And then we have to be more careful with version control and what's in production. And did somebody, do a git pull on that node suite? Now it's broken for everything. I mean, it just gets complicated, just like everything else we do in development. Yeah, groups are on here. You just right click and say add group and it'll create one. So it's not the world's nicest UI for that kind of thing, but for the most part, it keeps everything together and glued. Is the Comfy manager something that would be standard to Comfy? Again, the manager is made by the same guy who makes this impact pack, and I don't know that Comfy himself has decided whether or not this is something he's going to make permanent. He does that with some nodes. I do not know his strategy behind which ones he will and which ones he will not. But a couple of the developers of these node suites have since been hired by Stability. So I know that we are bringing those people in, and I don't know, again, where people are in this, but I use this guy's, a lot of his tools a lot and interact with him quite a bit. So very talented developer, but who knows what the strategy is for when those people are going to be involved or more involved or less involved with this product. But this manager has saved a lot of us from having to do git pulls on every single node suite we have, because I have a lot of them in here. That way I don't have to go in. I can just go into my manager. I can go to my install custom nodes and I can say, okay, what ones do I have installed? These are the ones I have installed. So I don't have that many, but I have some that are pretty interesting. Some that are just experimentation. Some doing with efficiency and tiled, like we can tiled sample, clip segregation, all kinds of different things like that. So are the changes made in Comfy represented in the code of the model? Represented in the code of the model. I don't know what you mean by that. The Comfy itself is a very lightweight backend, and then all the custom nodes may have requirements for the models that they're loading. Yeah. Oh, yeah. That's an interesting thing about this too, is if you take any image that's been done in Comfy and you drag it into the interface, it will load that exact workflow. So every image that comes from Comfy contains all the image information or all the graph information. So as long as you don't upload it to a system that strips that metadata, you can freely share these. You can also put it as a JSON, yes. But I don't want to look at the JSON file. I want to look at the picture. So I can go and I can grab the picture that I want. And in fact, some of these other ones we have different ones here. You can create different workflows. So if you say, well, today I want to work on, say I want to work on the SDXL code base, here's the XDSL code base. So this one is a little bit different than the one I was showing because it uses two different clip models. We use a G and an L. One's more of a linguistic positive, and the other one would be more of an artistic positive is the way you look at it, because we can break it up like that. SDXL contains both clip, so we can use it that way if we want to. Or you saw in the example that I had, I did not use it that way because it didn't really need it for that. So yeah, there you go. Any other questions? Keep them coming.
Yes, talking about that JSON output, sorry. Why I asked that, because when you're trying to fine tune a model, there's some specific characteristics that are put onto the text to image model, whether it's a digital art or what. So that output that you get after you use Comfy JSON, for me as a developer, maybe it can help me to fine tune a model to generate maybe pictures that look more cartoonish or in a different way. So I think that was the question I was trying to ask there.
Well, I'm imagining that that's not going to be a concern. You should be able to do, again, anything. If you haven't, and someone has created a node for it, you can always create your own node to do, create the tools that you need to. But I know there's a lot of people who do a lot of training and they use this to generate a lot of their training sets. Now, you would use Koya or some of the other training systems for this. But if you're looking to, say, parameterize the images that you're going to create, absolutely, you can do all that with this. I mean, that again, it's simply nodes. So you're just hooking them together saying, now I need a node that's more text centric, for example. And there are so many nodes that I have just loaded myself in here. We've got all like math, for example, anything to do with graphics or Booleans, conversions to different types, numbers. Then there's lots of conditioning things we can do. We can condition like prompt only specific areas or mixed conditioning. We can batch together images. We can use IP adapters. We can use advanced IP adapters, which just came out this morning. The guy who wrote the Comfy nodes for the IP adapters have added some pretty cool regional capability. Again, so it's already done. And I just updated today and I have it already. Another benefit of this kind of little tiny, it's a 1,000 hands all working together type of mentality, is we already have that implemented. And the Comfy core code itself doesn't change very often, which is really nice. So I've had success with XYZ plot. Yeah, I have actually an XYZ, didn't I? I guess I don't. Oh yeah, this one here. The trouble is that a lot of these, that error popped up. This is the one we're all crying about right now. Although it's been forked since then, is the guy who made these efficiency nodes for XY plotting has discontinued the whole Git for it. Well, somebody had forked it, and now I just have to go get that. But this is one of those things that you get sad about, is you see someone create a node suite that you love, and then they decide it's just not worth the time or trouble to maintain it. And that's another reason why, like, when I find somebody who has a node suite, I'm a really big fan of giving back to them. And when Git has the ability for you to gift developers, I wish everybody would turn that on for making some stuff. Like, there are people that I'm giving $5 a month to for Patreon. I would give $5 a month to have someone keep these node suites active and interesting, like spread the love. If we're all doing that, everybody's helping everybody else out. Everybody wins, right? So this made me kind of sad, but again, it has come back. This is another really interesting one here. The LoRa block allows us to manipulate which parts of the LoRa, because the LoRa, like in SDXL, is 20 blocks wide. We have 3 in the middle, and then we have all the sides. We can go through and input variables, for example, to see which parts of the LoRa actually do things to the image we want versus create junk. Especially if we're merging 2 LoRas together, we can merge, say, the blocks at the beginning of one and the out of another and not have them step on each other. So there's a lot of really kind of cool capability in there. So it's not just like, hey, I'm going to add a LoRa at 100% weight or 50% weight. It's like, no, I'm going to add it at 100%, but I'm going to add this specific area at like 300%, and the rest of the model I'm going to zero out. So there's a lot of neat stuff. Now, you can do this in Automatic 11.11 as well, but you have to go and download it and then put it in there and then find it and then enable it and remember to do that. And this is just easier to me because it's in my face, right? It's right. It's part of one of my workflows. So, yeah. Any other questions, comments, witticisms, criticisms, heresies, or fallacies?
I think we're coming up on time here. I think we've covered pretty much all the questions. So yeah, I guess maybe we can kind of wrap it up there if that's cool with you, Scott.
Yeah, it's all good.
Sweet. Well, I guess let's leave it there. Thanks so much to Scott, to Dakota for presenting. Like I said, as you all kind of go on, if you play around with all this stuff and you get stuck or have questions, we'll definitely happy to connect you to the Stability team to get unstuck. And yeah, we'll record this and send it out as well in case you want to, go back and what was that one little step that Scott did that you need to remember. So you can go through on your own time as well. And yeah, we'll see everyone who's coming to the workshop tomorrow. So yeah, the fun doesn't continue for us in the program. All right. Have a good one, everyone.